Bismillahirrahmanirrahim. In today's video, I am going to cover a very important topic, and that is the exact calculation of QRS axis of the heart on ECG. So we start with the basics. Suppose this is the person whose ECG is being performed, and this is his heart, and we have already discussed that the net vector of the electrical impulse is something like this. And to calculate the QRS axis, actually there is a role of sphere in it. We know that this is the right side of the body and this is left side of the body, and we have already discussed that lead 1 and AVL, they look at the heart from this side, and lead AVF from this side along with 2 and 3, and all other leads like AVR from here and just well, we are going to focus on only lead 1 and lead AVF in this video to calculate the axis. And to make it simple, I will be drawing only this surface, this circle here. So this is our circle, and this is right side and this is left side. So we basically divide this circle first into two with a line that is drawn just in the center of the circle horizontally, and a 0 degree is on the extreme left side of the circle, and 180 degree is on the extreme right side of the circle. Now, as we're going to calculate the axis in degrees, we must be measuring it in degrees as well. The upper portion of the circle, it corresponds to negative, and the lower portion of the circle corresponds to positive, right? And we have already discussed that the normal direction of the vector of the electrical impulse is something like this, or it can also be something like this with a little variability, or it can also be somewhere here. So normally these variabilities exist, so we conclude that in a normal person, the normal axis of the QRS complex, or broadly speaking the axis of the heart, it lies between minus 30 degree to plus 90 degree. In this side we gradually move towards 180, but here the calculation is something like this, is in the minus form, like this is minus 30, this is minus 45, this is minus 60, and exactly the top it's minus 90, and then minus 120, minus 150, and reaching 180. Similarly here, plus 30, plus 60, plus 90, plus 120, and plus 150. So now how to calculate the axis in the ECGs? We have to look at lead 1 and lead AVF, as we have already discussed. And in this circle we plot the horizontal line as a lead 1 and the vertical line as AVF, which has positive direction on the lower side, and lead 1 will be having the positive direction on the left side. So now suppose that we have an ECG and we are going to focus on the QRS complex. Suppose the QRS complex in lead V1 is something like this, and in lead AVF is something like this. Now the first important step is to calculate the RS difference in lead 1 and lead AVF. The RS difference is the number of small squares in R wave and number of small squares in S wave and their difference. We have already mentioned that R wave is the first upwards deflection in a QRS complex, and the negative deflection following the positive deflection in the QRS complex is the S wave. So if we calculate, suppose these two are drawn on an ECG paper, and now we want to calculate these small squares in R wave, be it 1, 2, 3, 4, 5, 6, 7. Suppose this is 7, and in the small squares in S wave, suppose this is 1, 2, 3. Suppose this is 3 small squares. So this is 7 minus 3, and the RS difference will be 4. Now please keep it in mind these values. Similarly, we are going to calculate the RS difference in lead AVF now. Suppose this is the R wave is 1, 2, 3, 4, 5, 6, 7, 8, and S wave is 1, 2. Suppose this is 2 small squares. So it will be 8 minus 2, and it will be equal to 6. So we have to remember both these readings for the calculation of the axis, which I'm going to calculate in the next slide. Now we've already calculated the RS difference in both lead 1 and AVF, and now we're going to plot it here, and we have discussed that this is lead 1 and this is lead AVF for the calculation, and in case of lead 1, this side is positive, this is negative, and in case of AVF, this side is positive and this side is negative. Ideally, these calculations should be made on a graph paper, but we are going to assume that it's a graph paper and it has got squares, equidistant squares like this. Clinically or in hospital, we can also calculate on an ECG strip, which is also almost the same as a graph paper, as it has got equidistant squares. So we are going to put our values that we calculated, the RS difference values here. In case of lead 1, the RS difference value was plus 4. So this is the lead 1 line. So we will write here. Suppose this is 1, 2, 3, and 4. Right. And similarly, the lead AVF value, the RS difference value was plus 6. So we will draw it here. So this is 1, 2, 3, 4, 5, and 6. Now we're going to extrapolate this like this. We will draw a line here, and we'll draw a line here, and these two lines coincide at one point here in this point. Now I'm going to draw another line that joins the central part of this to this point. Now this point is reached and we have to calculate this angle. We have already discussed that this is 0 degree and this is plus 90 degree and this is 180 degree and this is minus 90 degree. So we will calculate this angle. So this is almost plus 60 degree. So that's how we have exactly calculated the axis of the QRS complex of the ECG we had. Now I'm going to give you another example to clarify. Now suppose this is the QRS complex in lead 1 of an ECG and this is the QRS complex in lead AVF of an ECG. Again we have to calculate the RS difference here. So suppose this is 1, 2, 3, 4, 5, 6, 7, 8. This is R and the S is 1, 2, 3. So 8 minus 3 is equal to 5. Keep it in mind. Again in AVF the R is 1, 2, 3 and S is 1, 2, 3, 4, 5, 6. So it's 3 minus 6. So it's minus 3. Now we are going to put these values 5 or plus 5 and minus 3 on our graph. Again vertically AVF, which is positive here and negative here. This is AVF, and horizontally lead 1, which is positive here and negative here. Now I'm going to mark these values on this axis. In lead 1 it was plus 5, so I will draw 1, 2, 3, 4, 5 here, and in AVF it was minus 3, so it will be in this direction. So I will draw 1, 2, 3, minus 3. Again I am going to draw lines to extrapolate that. This line in here and this line here. So again I will draw a line to connect these 2 points. The point where these lines have coincide and the center, I will now connect it to the center. This. Now we have to calculate this angle. So it's almost, we have already discussed that this is 0 and this is minus 90, and this will be between 0 and minus 90 will be minus 45, so it's almost minus 40. So we have already discussed that a normal axis is between minus 30 and plus 90, right? But here the QRS complex axis of this ECG is minus 40, so it's more negative than minus 30. So any axis that is more negative than minus 30 is called left axis, or it will be called as a left axis deviation, right? So any axis falling this direction or in this square here from minus 90 to here in this area. Actually, this is the area that will be called as corresponding to a left axis deviation. Now suppose our axis is falling into this area from 180 to minus 90. Here the axis that falls here, that is also called as extreme right axis deviation. And similarly, the axis that falls here in this quadrant, that is more positive than plus 90 to 180. In this area, this axis will be called as right axis or right axis deviation. So now to simplify this figure, I'm going to draw it again. This is our square and these are our reference lines. This is minus 30 and this is plus 90. This area is the area of the normal axis. Again, this area is the area of left axis deviation, and similarly this area corresponds to right axis deviation, and finally this area corresponds to extreme right axis deviation. So I hope I have covered most of the things regarding the QRS axis. Thank you very much.